Hi guys, I am Ankit. In this video, shows another problem on LeetCode. Degree of an array. So given a non-empty array of non-negative integers, the degree of this array is defined as the maximum frequency of any one of its elements. So your task is to find the smallest possible length of a subarray of given array such that it should be has the same degree as the original array. So the given question is degree of an array means it's nothing but it's the maximum frequency of one of the elements of the array. So if we take the first example here, the maximum frequency which you can find is for 2. It's appearing twice. So this is the maximum frequency for the given array. From this we have to generate the subarray, and that subarray, as you know, what do you mean by subarray? Subarray is nothing but the array part of an array which is in contiguous. That means maintain the relative order of the elements as such. So if I take 2 to 3, this can be a subarray. If I take 1 comma 3, then no, this cannot be a subarray because they are not contiguous. So 2 to can be a subarray, 2 to 3 1 can be a subarray, the entire array can be a subarray. But here we need to find the smallest possible length of the subarray that has same degree as the original array. So original array degree is 2 as we saw because 2 is appearing twice. So what is the smallest possible subarray you can generate with the same degree as the original array? That is 2 comma 2 itself. If you take 2 comma 2, it's a subarray because they are in contiguous order, and the degree is also 2. So this is the smallest subarray and we have to return the length, that is 2. If we take the next example, okay, here the maximum will be 1 is appearing twice, 2 is appearing thrice, 3 once, and 4 once. So maximum the degree of the array is 3 here because 2 is appearing thrice. So this is for the original array. We have to find a subarray that has the same degree. So if it needs to have the same degree, that means all the three twos must be included in the subarray. Only then that array will have the degree of 3. That is for sure. So if we include a starting point and ending point of those two, then the subarray what we get is of length 6. So we are returning answer as length 6. So whatever degree you get, the starting element of that particular giving element that is giving the maximum degree and the ending element, that should be the length of the subarray. The difference between those two indices. So another possibility is, let me take this example now. So we take 1 is appearing thrice, 2 is also appearing thrice. So in this case, there are two elements with the same degree. That is the highest degree. 4 is appearing once. So 1 is appearing thrice, 2 is also appearing thrice. So the maximum degree of this array is 3, and the element that is making this degree as 3 are 2 and 1. So which in this case we'll see the length of the subarray if we take 1. Then what is the length of the subarray width? So starting point at which one occurring is over this point and ending is over this. So the length is 1, 2, 3, 4, 5. 5. 5 is the length for 1. If we take for 2, starting point is here, ending point is here. So it's a length of 6, which is the minimum of these two. 5. So you have to return 5 as the answer. So one case which you need to handle is there can be more than one element that is having the same degree, that is the highest number of occurrence of that element with the same degree. So in such case, we have to look into the subarray that is giving the minimum length and take those subarray. So let's see how do we solve this problem. Okay. So as I said here, first we need to find the frequency of each element, how many times it is appearing in array. And one more thing is we want to get to starting position. Ending position we want to know, but we will have a map for storing the starting index of the first occurrence of that element. Okay. So what we'll do is we'll have two maps. One map it is containing the frequency at which the element is appearing. So one is appearing thrice here. So one is appearing thrice. Then two is also appearing twice. 4 is appearing once. Okay, this is the frequency map. And other map, let that be having each element and its first occurrence. So 1, what is the first occurrence of 1? It is at 0th index. Okay. Then 2 if you consider the first occurrence at that first index. Then 4 if you consider first occurrence at 0, 1, 2, 3, 4, 5. Fifth index. Index at position 5th. 5. So now this is what? This is the first occurrence of each element. Okay. You might ask why are we not storing the last occurrence of the element? That we will compute during the looping itself. Okay, we'll have the first occurrence and we have frequency map. Now what we will do is we start here. We'll maintain two variable. One is minimum length. Of course, you need to have minimum length, right? So let the minimum length be initialized to maximum value. Let that be int max. Okay. And another variable called maximum frequency unit. Maximum frequency is nothing but degree. So let that be initialized to 0. So minimum length is initialized to maximum because minimum length is for the subarray. Maximum frequency is nothing but the degree. So now you run the loop. Okay. This is the array which will be formed. But before forming this, let's say we start with the loop. So we start with the first element. This is the end result. Right now we are not having this. Okay. We start with this. You check whether 1 is present. 1 second. Okay. So yeah. Now you check whether 1 is present in the frequency map or not. Is it present in the frequency map? Sorry, you're not checking in the frequency map. You need to check whether 1 is present in the first map or not. Is it present? No. Initially, first map and frequency map are empty. As I said, you just don't consider this now. Okay. Right now, frequency map and first are empty. So you check whether 1 is present. No. So this is the first occurrence of this element. Right. So we store 1 with index 0 in the first map. And this is frequency map. And frequency map, you have to increment the value from 0 to 1. Okay. So once you get this, so you calculate a degree. Let's have a variable. How do you get the degree? Degree is nothing but the value of this frequency map, right? For this given element, what is the degree? The value of the frequency map. So what is the value of the frequency map you are getting for this element 1? That is 1. So right now the degree is 1. Now check whether this degree is greater than the maximum frequency. Max frequency. Is it greater than maximum frequency? Yes, it is. If it is greater, is 0 greater than 1 greater than 0? Yes, it is. If that is greater than maximum frequency, that means maximum frequency equal to this degree now. So maximum frequency will be initialized to degree. So this will become 1. And one more thing, not only this, another thing we have to calculate now. That is the minimum length. So what will be the minimum length you will be getting? So minimum length will be equal to the index at position this occurs minus first index, that is the value of the first map. So array of, not array, okay, value of this first map nums of I plus 1. Why plus 1? Because that is starting from 0 to index. Only then you get the length. So currently I is pointing at 0. 0 minus 0, that is 0 plus 1. So minimum length is 1 now. So this has become 1. So we are calculating the minimum length only if the degree is greater than maximum frequency. Otherwise, we will not calculate the minimum length. Okay. Other condition will be we might get degree equal to maximum frequency also. Degree that is equal to maximum frequency. When will you get it? See, for 1 also you'll be having the degree as 3 and 2 also is occurring 3 times. At this case, at this point you will find degree equal to maximum frequency. That case we will handle it later. For now, we are just checking. We get the element. If it is not present in the first map, then you put it. That will be the first starting index you get it. Then you increment the value in the frequency map also. Then you get the degree. So the degree, if that is greater than the maximum frequency which is already obtained previously, then you reinitialize maximum frequency the current degree and minimum length will be calculated for this element. So minimum, how do you calculate? The position at which currently the element is occurring minus the first position. As I said, how do you get the subarray length? The first occurrence and the last occurrence. So if you are in the middle, like say 2 and this 2, so this 2 will be stored at 0th position in the first map and you are at this position. Now 2 This to this length, that is 2 you have to get. So index at this position is what? 0, 1, 2. 2 minus 1, 1 plus 1. You get the length of 2 as a minimum length of the subarray. So after this, let's move to the next element. Now check whether 2 is present in the first map. No. Again, the starting index of 2 will be 1. Then you have to increment the value in the frequency map also. Once you increment it, um, you have to calculate the degree. What is degree of this particular element? That is 1. Value of the frequency map of this element, that is 1 only. Again, check whether degree is greater than maximum frequency. No, it is not greater than maximum frequency. It is equal to maximum frequency. Actually, maximum frequency is 1 now. So will not do anything. And whether degree is equal to maximum frequency, this degree is equal to maximum frequency. Yes, it is equal to maximum frequency. In this case, you find the minimum length will be equal to minimum of minimum length, already existing length, comma minimum length for this subarray. What will be? Again, I minus first of nums of I plus 1. So you have 1, comma the minimum length, what you get here? 1 minus 1 plus 1, that will be again 1 only. So it will be 1 itself. The minimum length will remain the same. So what happens is, if you get the same degree for two elements, then you check whether the subarray length of that element and this element, which you get the minimum, which of them get the minimum, because minimum length will be already having for the element that is previously calculated, and the current minimum length also you check, and whichever gets minimum of those two you will take it. So you will get clear idea when you reach end of the loop. So okay, next we'll move to the next element again, to whether 2 is present in first map. Yes, it is. You will not change the starting index now. It is 1 only. Now, but we have to increment the value in the frequency map. It's occurring twice now, so 1 will be incremented to 2. I'm just explaining the logic. The code wise, we'll be programming it later. So, increment the value to 2. Now, what is the degree of this element 2? Value in the frequency map, that is 2. So, it is 2. So, is 2 is greater than the maximum frequency, that is 1? Yes, it is. If it is greater than, now the maximum frequency will become 2. And you have to find the minimum length. What is the minimum length? As I said, I minus the first occurrence of that particular element plus 1. What is the current position you have? 0, 1, 2. So 2 minus, let me just write the index 0, 1, 2, 3, 4, 5, 6. So 2 minus first occurrence is 1. 2 minus 1, 1 plus 1. So length is 2. So minimum length is 2 we are getting. So minimum length will get incremented to how much now? 2. Okay, this is else if condition. If this condition happens, you need not check for else if. So we are done with this. Now you see the minimum length which you have obtained till here at this point is 2. That is right. So next again move the pointer ahead. 1, it is already present in the first map. You will not be changing it because some first index already been occurred. Now increment the value in the frequency map to 2. So what is the degree? 2 again. So if degree is greater than the frequency map, no. Is it equal to the maximum frequency? Yes, it is equal. So if it is equal, you find the minimum length of which subarray has a minimum length, either for the 2 or the 1. So minimum length is already what we have as 2. And I minus first of I. Why it is I pointing to 3 minus the first occurrence of this element 1. That is a 0. 3 minus 0. You could say 0, right? 3 minus 0 plus 1, 4. So which is the minimum of these two? You get 2. So minimum length will be 2 itself. Got it? See, at this position, till this position, we are having 1 is occurring twice, 2 is also occurring twice. That is okay. Both the degrees are equal and they're highest. But which array element is, if you consider it is giving the smallest subarray, that is 2. Because for 1 we are getting the length as 4 and for 2 we are getting the length as 2. And you take minimum of those two. So this is the previous element and the current element. If we get the degree equal, then you find the minimum of the subarray length and take it as the maximum minimum length. So again the minimum length will be 2 only. Okay. So this is why I said we need this condition. So next again move the pointer. 1, it will get incremented. First map nothing will change. It will get incremented to 3. So at this time degree will be 3 and it is greater than maximum frequency, that is 2, right? So maximum frequency will become 3 now, and the length also what will be 4 minus 0 plus 1, that is 5. Yes, 5 will be the length. You might say 2 is having a minimum length of 2 here, till this position I'm telling, only till this position. But 1 is occurring thrice, the degree is 3 for 1, and for 2 it's only degree is 2, which is maximum degree we are getting, maximum frequency we are getting, that is 3. So here the degree is not equal in this case. That's why the maximum frequency is incremented 3 and the length also incremented to the subarray. Having the degree, highest degree will be incremented to 5. Got updated to 5. Next again move to the next element. 4. Check. 4 is present in the first map? No. So store the index, starting index, what it is, 5. And so value will be also incremented in the frequency map. So in this case degree is 1 actually. If 1 is greater than the maximum frequency, no. Is it equal to maximum frequency? Even that also doesn't have. So move to the last element, 2. So 2 is already present in first map. You don't change the first index, starting index. Yes, it is present in the frequency. We'll increment the value to 3. So the degree will become 3 now. Is 3 greater than maximum frequency? No. Is it equal to maximum frequency? Yes, 3 is equal to 3. So in this case, again you check. The minimum length what you already have is 5. And minimum length for this element 2 is what? 6 minus first occurrence of 2 is 1. 6 minus 1, 5 plus 1, 6. Is it right? 6 is the length of the subarray if we take the degree as of the element 2. 2 starting index is 2 is here, ending index is here. So that is the length of 6. For 1, starting index here, ending index is at this position. So length is 5, which is the minimum of these two, that is 5. So you get the minimum length as 5, which was the answer we had seen in the before question, before solving the question. So this is the approach to solve the problem. So we shall program this now. Okay. So first we'll, okay, this is C++, so I should mention size. Then after this, as I said, we'll initialize minimum length equal to int max. I'll explain the Java logic also later. And we'll have a maximum frequency value. Okay, maximum frequency value should be int max. Sorry, it should be 0. Yeah. Minimum length will be int max initially. So once you're done with this, now we should have the map. So let's just create a map, unordered map. In comma int is the key value pair. So let's name it as frequency map. Another unordered map. Even that is of in comma int. And so let's name it as first. So now run the loop. So first we need to check whether this particular element is present in the first map or not. So if first dot find of nums of I equal to first dot end, if that is pointing to end, then that element is not present in the first map. So you have to store the index of that. Nums of I will be equal to I, the particular index at which the element is occurring, that is the starting index. And simultaneously you have to increment the frequency map value also. So frequency map of nums of I will get incremented. Okay. So once you're done with these two, checking these two, then what we do? We calculate the degree. So what is degree? Degree is nothing but the value of the frequency map of that particular element. So frequency map of nums of I. So that is the degree you get it. So once you get the degree, first you have to check whether that degree is greater than the maximum frequency. Now check whether degree you have gotten is that greater than the maximum frequency. If that is greater, then degree maximum frequency will be equal to initialized to degree. And also you have to find the minimum length equal to, what is the minimum length you get? Okay, that is the index at which currently the element is occurring minus the first starting index. Starting index, how do you get it? It's from the first map. Nums of I plus 1. 1 because we are having the zero index there. So that's why. Else if another condition, what if the degree is equal to maximum frequency? If that is the case, then minimum length will be equal to minimum of two subarrays. So one is the minimum length already which we have, and the current element what we get the minimum length plus 1. Yes. So at last we have to return the minimum length. Okay. Yes. And for Java, only the syntax change you will have. So this is the way you create the map here. Then integer.max value initialize it to minimum length, maximum frequency. You check whether that key is present in the uh, frequency map or not. If not, then you just put it into the map. Then yeah, it should be first. Okay. Then frequency map. If you have already element, then you just increment the value by 1. If default you get it. If you don't get anything, then you default initialize it to 0 and increment the value by 1. Then you get the degree, check whether degree is greater than maximum frequency or equal to maximum frequency, and you handle the cases and return the answer. Yes, we shall submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.